Hello class, my TLA 9 students. Welcome to TLA Electrical Installations and Maintenance in C2. Right, our lesson for today is about carry out measurements and calculations. So we have two tasks for today. First is to measure the actual voltage and electric current. Alright, so this is our instruments. We have the multimeter. This is called multimeter because this can function as ohmmeter, right? This can function as your alternating current voltage meter. This can function as your direct current voltage meter. And also this can measure the capacitance of your capacitor. But this time we will use only ACV meter and DCV meter for battery and for the alternating current voltage coming from your outlets. Okay, so for electric current we're going to use this clamp on meter. So the current that we're going to measure is only from 2 to 20 amperes. Okay, that is why our setting must be only from 20 amperes. Okay, so if you see this is 2 to 20 amperes, this is 200 to 400 amperes. Okay, so please bear with me. Let us now proceed to actual demonstration. First, we're going to measure the voltage of this outlet. Okay, once again, this is alternating current voltage. So this does not follow a certain positive and negative polarity. Right, so there's no polarity here in our alternating current voltage. That means this positive rod and this negative rod, we can use this, no? Our setting, okay? In this way, look, we can see it's measuring the voltage. Okay, or we can also interchange. We can interchange this one. Okay, interchange, and there could be no problem. Okay, so that is on the alternating current voltage. Now look, we have a setting of 250. So between 200 and 250 it must be 225. So but our pointer says it is 215, right? This is only 215 volts. Okay, so let us put this on record. Our voltage is equals to 215 volts. Okay, so let's proceed to electric current. Using our clamp meter, then we can determine how much current is flowing in a circuit with this electric flat iron. So let's plug in. Now it's functioning. So let us measure now the current flowing in a circuit. So look, this is 3.93, 94, 95. Okay, so it's fluctuating. So let's hold. Okay, now we have 3.94 amperes. So let us put this on record. Our electric iron, it draws 3.94 amperes. Okay, now what we are going to do now is to calculate how much power is being generated by the electric flat iron. So we can determine the formula by using the power triangle. Okay, the power triangle. So this is letter P, this is letter V, and this is letter I. P stands for power in watts. Okay, I stands for intensity of current flow, current in amperes. V stands for electrical pressure or voltage in volts. Okay, so looking for the value of power, so P must be V times I, or voltage times current in watts. Okay, so we can use this formula in finding the power of electric flat iron. So substitute P now is equals to V times I, or V stands for 215 times current, which is 3.94, so equals to 215 times 3.94, so this is 847.1 amperes. Okay, sorry, this is watts. Okay, so let us convert now this 847.1 watts into kilowatts by dividing it to 1000, right? 1000 is equals to 1K. So this could be 0.8471 kilowatt. Now remember that the electric bill is measured in kilowatt hour. So example, this electric flat iron is used by the owner for up to 1 hour a day. Okay, so using electric flat iron in 1 hour, we can get kilowatt hour. So this could be 0.8471 kilowatt hour. So how to get the price now of the electric bill? It's simple. Let us multiply it with the price of electricity today is 12.5 pesos per hour. Okay, so let us multiply. Right, 0.8471 kilowatt hour times the price, which is 12.05. Right, the result is 10 pesos point 27 pesos per hour. Okay, so class, this is the price of electricity using your electric flat iron for 1 hour. Right now class, this is your tasks for this demonstration. You can post this video and you can do your task now. Let us determine how much are we going to pay for 1 hour use of this stand mixer. Right, so I'm going to show you how to measure the current. Alright, but you can pause the video, and after that you can solve for the total power and then the price of the electricity per 1 hour of use of this mixer. Okay, so that's your task. Alright, so let's proceed to demonstration. Let us get ready with our meter now. So we have to place this. So we have standby current. Okay, we call this standby current. Standby current of 0.069. Now the moment we turn on this mixer, and now it's functioning. Let us see how much current is flowing in the circuit. So that is 0.698, 0.700, 0.6. So it's fluctuating class. So anyway, we can hold by pushing this yellow button, right? So that's it. So we have a maximum of 0.707. Now let us try to maximize the speed of this machine. From 1, we can set this to number 5. Okay, then now you notice that the current is also increasing up to 0.830. Alright, so the maximum current is 0.833. So let's put this in record, class. Now this is your task. Solve for the total power, and then how much are you going to pay if you are going to use this stand mixer for 1 hour. So remember, the data we collected is the current. The current is 0.833 amperes connected to 215 volts, right? So using this power triangle, class, you can now proceed to your activity PVI. So look for the value of power and then determine how much are you going to pay for 1 hour use of this stand mixer. So pause the video, but let me proceed to my demonstration. Okay, so let's substitute. P is equals to V times I, right? V, we have 215, right? Times 833 amperes. So let's calculate. 215 volt multiply by 0.833 amperes, then we'll get 179.095 watts. Okay, then let us convert this into kilowatt by dividing it to 1000, because 1000 is equals to 1K, right? So we can get P is equals to 0.179 kilowatts. So now we have converted 179 watts to 0.179 kilowatts. But remember, the electricity is measured in kilowatt hour, correct? In kilowatt hour. So let us assume that you used your stand mixer for 1 hour only. Okay? So 0.179 times 1 hour will get the result of 0.179 kilowatt hour. Okay, so let's proceed. How much the price now of using stand mixer in 1 hour? Let's multiply this with 12 pesos 0.5. Okay, this is now the price of electricity per kilowatt hour. So let's multiply 179.095 times 12 pesos point 05. Right? So the price for electricity is 2 pesos. 2 pesos and 156 centavos. Okay? 2 pesos and 156 centavos per hour. Okay? So now let's compare the stand mixer. For 1 hour use, we can use only, or rather we can pay only 2 pesos and 156 centavos. But for electric flat iron class, will pay a lot, no? So meaning to say, electricity in using electric flat iron is much bigger than the use of stand mixer, and also the power generated by electric flat iron is much bigger than stand mixer. So the reason why we're going to pay a lot using electric flat iron versus stand mixer. Alright, so I want you to submit your task I have given to you. Okay, please submit that in the group chat, or no, I think you can submit to me through my personal message account or through email. Right, our last demonstration is how to measure the stored voltage in this battery. So there's a little difference in measuring ACV to DCV, because DCV observes polarity. Okay, so you have to observe the polarity. The positive sign is the positive side of the battery, and the negative sign is the negative side of the battery. So you must know how to use your tester then, right? The red one is the positive rod. No, this must be placed correctly to the positive side of your battery, and the black one is the negative rod, right? So first we have to set our meter. Again, you should have a pre-knowledge how much voltage are you going to measure. So for this 9-volt battery, right, we can set to 10 volts, right? 10 volts. Now how to read? Look, we have here 10, 8, 6, 4, 2, and 1. Have you seen it? 10, 8, 6, 4, 2, 1. Alright. So since this is 9 volt, okay, if this is good and still functioning, it must be between 8, 9, 7, 6, right, along this side to still use this battery, right? So let us proceed to demonstration. So the positive, that means this is your red one, and the negative is your black one. Now let's see, it's moving, but it is less than 1 volt. You see it? It is less than 1 volt, right? So that means our conclusion is this is very weak, and this is to be discarded properly. The next one is your single seal or dry seal. So this is the negative, and this is the positive side of your battery. That means the positive, let us put the red one here, right? And then the negative, let us put the black rod here. Now it's moving, and according to our pointer, it is less than 2 but more than 1. So exactly this is 1.5 volt, right, which is correct. No, this is correct because our dry cell is, this contains 1.5 volt direct current voltage, right? So thank you very much, class. Once again, I'm going to repeat the submission of your tasks assignment. Submit through our Google Classroom, right? Second one, you can submit it through my email. Alright, thank you very much. Good luck.